Good morning, students. We are discussing the numericals of colligative properties. Today we will see some numericals relating to depression of freezing point and osmotic pressure. So now you see the problems here first, that 45 gram of ethylene glycol is mixed with 600 gram of water. Calculate the freezing point, depression and the freezing point of the solution. So here ethylene glycol, 45 gram of ethylene glycol, that is dissolved in a 600 gram of water. That means here ethylene glycol, that is your solute, and 600 gram of water, that is the solvent. So after adding this in a water, we have to find out the freezing point depression, that means delta TF we have to find out, and another the freezing point of the solution. After adding the ethylene glycol, what will be the freezing point of the solution? So you see here, we know that delta TF, that is equal to Kf into m. So delta TF, that is depression of freezing point, that is Kf means cryoscopic constant and molality. So here to find out the molality first, what we have to do? We have to find out the moles of ethylene glycol, that is the solute. So given mass of the ethylene glycol, that is 45 gram. So given mass divided by its molar mass. So this will be the number of moles of the ethylene glycol. So this moles of ethylene glycol, that is 0.73 mole. Now mass of the water, that is given in gram, 600 gram. So we have to convert it to the kg. That means we have to divide it by the 1000. So it will come to that of the kg. That means it will be 0.6 kg. So therefore molality, and that will be equal to 0.73 mole divided by 0.6 kg. So that will be the molality, means 1.2 mole per kg. So therefore the freezing point depression, that is delta TF, that is Kf for water into m. So Kf for water is 1.86 Kelvin kg per mole into 1.2 mole per kg. So that is coming to that of the 2.2 Kelvin. So the freezing point of the aqueous solution now, so that this is the freezing point of the water, so minus depression of the freezing point. So that will come to that of the 270.95 Kelvin. So this is the numericals regarding that of the depression of the freezing point. So now we will see the another numericals relating to that of the osmotic pressure. 200 centimeter cube of an aqueous solution of a protein contain 1.26 gram of the protein. The osmotic pressure of such a solution at 300 Kelvin is found to be this much bar. Calculate the molar mass of the protein. So here you see that we have taken the 200 centimeter cube of an aqueous solution which contains 1.26 gram of the protein. Now osmotic pressure of such solution at 300 Kelvin, that is given this much, pi is equal to this much. Calculate the molar mass of the protein. So we have to calculate the molar mass of the solute here. Protein is the solute here. So we know the relation regarding that of the osmotic pressure, that molar mass M2, that is equal to W2 RT by pi V. Here W2, that is the mass of the solute, R, that is a gas constant, T, that is a temperature in Kelvin, pi is the osmotic pressure, and V is the total volume of the solution. So now here V, that is given 200 centimeter cube. So that means we have to convert it to that of the liter, then it will come to that of the 0.2 liter. Temperature, that is given, that is a 300 Kelvin. So temperature, that is 300 Kelvin. And R we have to remember, that is 0.083 liter bar per mole per Kelvin. That quantity you have to remember, that is a constant, gas constant. And pi here it is given, that is the osmotic pressure, that is 2.57 into 10 to the power minus 3 bar. So that means here that pi is given, that is 2.57 into 10 to the power minus 3 bar. And W2, that is the mass of the solute. So that is given how much protein, that is 1.26 gram protein is dissolved here. So that means W2 is equal to 1.26 gram. So therefore M2 that is equal to W2 RT by pi V. If you put the value here, the corresponding value if you put, then this will come out like that. So here you see now that gram, this gram will remain there. Now that bar divided by this bar, so that will cancel out. Per Kelvin and Kelvin, that will cancel out. So here liter, this liter, that will cancel out. So now gram per mole, unit will be gram per mole, and if you calculate this, ultimately it will come to the 61.022 gram per mole. So that will be the molar mass of that protein. So this way you have to do the numericals of the colligative properties. We have got the 4 colligative properties, and we have discussed the 4 numericals from each one, and you have to do more numericals. Later on I will also provide you the numericals. You have to do yourself. So thank you for today. Thank you.